Welcome to homework.
When we look at 2,4-hexadienoic acid, the big thing that we see here is that it's a carbon chain. So it's a hexanoic chain. So it has 4 carbons, but it has 2 double bonds, right? So that diene is a 2 double bonded structure. We know it's an oic acid, so that means it's a carboxylic acid on one end. Now, the main thing we're worried about here is the cis and trans isomers of those 2 double bonds. When we look at our structure, okay, so what we can consider is that it's a 6-carbon chain, right? So when we look at this in terms of our double bonds, I'm going to draw one here as an example, okay? I'm going to look at this. So this is our CH3 group, okay? And then this is our double bond OOH, okay, coming off this carbon here. When we see that, the way that I have it drawn here, when we look at these double bonds, the major carbon groups coming off of these are both cis. So this would be what we call a cis-2, cis-4 hexadienoic acid. Right, looking at that, basically the 3 other forms of this are just going to be the other options. Okay, so we can have a trans-trans, and if we do that, it's going to look just like, so if we have our double bond OOH, right, and our double bond here, this will be trans, which means it's opposite. And then on our second double bond, this will also be trans for our methyl group. Okay, so that's trans 2, trans 4, okay, hexadienoic acid. The other 2 options are just going to be mix and match. Okay, so it's possible to have one cis and one trans, and then vice versa, the other one cis and the other trans. Okay, so we have 4 total isomers